Hey guys, welcome back to my channel. So today we are going to discuss another interesting topic of electronic subject, which is PN junction. So let's get started.
PN junction. If one side of a semiconductor material doped with acceptor impurities while the other side doped with donor impurities, then there the p-type region is created on one side of the semiconductor and the n-type region on the other side. The interface on boundary between these two regions, n-type and p-type, is called a PN junction. So here is the p-type region and this is the n-type region. So the interface between these two region is called PN junction. When the one side of an intrinsic or pure semiconductor material like silicon and germanium doped with acceptor impurities atom, trivalent impurity atom like boron, gallium, indium, aluminum to build it as p-type semiconductor, and the other side doped with donor impurities, pentavalent impurity atoms like phosphorus, arsenic, antimony to build it as n-type semiconductor, where these two regions p-type or n-type are meet together, their PN junction is formed. So this is the p-type region and this is the n-type region. Where they meet together is the region which is called PN junction, and the anode, and this is cathode. Anode is positive and cathode is negative. So this is the PN junction circuit symbol and this is the PN junction diode symbol. So what happened in PN junction diode is the p-type region of the semiconductor has an excess of holes and the n-type region has an excess of electron. So being a p-type region, it has an excess of holes which is in positive in nature, and the n-type silicon has excess of electron which is negative. So in the PN junction semiconductor material, the concentration of electron in n-type region is more than the holes. So in n-type region, the concentration of electrons are more than the positive free holes, and the concentration of holes in p-type region is more than the electron in the n-type region. So what happened here is that in p-type region the holes are majority carrier and the electrons are minority carrier, and in n-type electrons are majority carrier and holes are minority carrier. These electrons repel each other due to high concentration in the n-type region. When a PN junction is formed, due to repulsion, some electron diffuse from the n-type region to the p-type region. As we know, the concentration of electron is high in the n-type region and the concentration of holes is high in p-type region. So they repel each other. They are recombined with the holes and in the p-type region because the electrons are attracted by the holes. Then the region of p-type, which is close to the PN junction, is takes on the positive charge because the electrons are departed from the n-type region. As we know, the electrons are attractive toward the holes, so the p region get closer to the PN junction, and the electrons from the PN region diffuse from n region to the p region. So across the junction, there is an inclination for the free electron to diffuse into the p-type region. So electron from the n-type region diffuse to the p-type region, and holes from the p-type region diffuse to the n-type region, and this process is called diffusion. The movement of electron from n-type region to the p-type region get attracted by the holes, and the holes get attracted by the electron is called, the process is called diffusion. So due to the diffusion of electrons and holes, an electric field region developed between the n-type and p-type region, and this is called depletion region. So there is a PN junction. As we know, the boundary between the p-type region and the n-type region is called PN junction. So there is a inclination of electron and holes are uh, made across the PN junction. So this make the electric field here, and this region is called diffusion region. This electric field is responsible for the movement of electron from the p-type region to the n-type region and holes from the n-type region to the p-type region. So this movement of charge carrier, electrons and holes due to the electric field is called drift. So the movement of holes from the n-type region to the p-type region and the movement of holes from the p-type region to the n-type region due to this electric field is called drift. So there is a voltage or potential difference across the junction due to the positive ion in the n-type region and the negative ion in the p-type region. This voltage or potential difference is called built-in potential or barrier potential. So what happen is that due to the negative electron in the p-type region and the positive hole in the n-type region, there is a electric field generated across the PN junction and it has the internal potential barrier. So this region we call potential barrier. So what happen is that if an electron wants to move from the n-type region to the p-type region and the holes wants to move the from p-type region to the n-type region, it has to overcome this potential barrier, and this potential barrier is 0.7 volt for silicon diode and 0.3 volt for germanium diode.
So guys, if you like my video, please do subscribe to my channel and press the bell icon for the latest update. And you can comment me as what topic do you want me to discuss in next video. See you in the next video. Bye.